All right, here we go. Here's some problems that have trig functions. Let's see if we can figure them out. So our first one here, this is just a matter of plug and check. I can plug in 0 here in the denominator and nothing's going to happen. So I can just plug in 0 for this one. It would be e to the 0, cosine of 0, 4, e to the 0 would be 1, because anything times to the 0 power is 1. Cosine of 0, though, is 0. No, it's also 1. All over 4, 1 times 1 would be 1, so our limit here is 1. All right, for number 2, what's wrong with this? If there was a 4 down here, what would the limit be? We just explored this, right? If there was a 4 down there, the limit of 4 theta, sine 4 theta over 4 theta would be 1. So what I'm going to do is make this the limit as theta goes to 0 of 4 over 4 times sine 4 theta over theta. So what did I do to this guy here if I put 4 over 4 in front of it? What is 4 over 4? 1, right? So I didn't change the value of it. I'm just going to change the way it looks so that I can use that understanding that the limit of sine 4 theta over 4 theta is 1. So notice here, I'm going to make this, turn this into the limit as theta goes to 0. I'm going to show you all the steps here so you know where I'm coming from. I'm going to take this 4 and actually put it over here. This is really 4 times sine 4 theta all over 4 times theta, which is 4 theta. So I'm going to rob the 4 from over here and put it over here. Can I do that? Sure, absolutely. Remember, if we were to multiply these, what would happen with those 4s? We cancel them out, right? And then we just end up with the original problem, which is up here. All right, now for my properties of limits, I know this is the limit as theta goes to 0, 4 times the limit as theta goes to 0, sine 4 theta over 4 theta. And now I know the limit of a number, right? A real number is just like numbers. This one's 4. And the limit of sine 4 theta over 4 theta, we just explored that. We know that's 1. So our overall limit here is going to be 4. We're going to do that a couple of times here so we can get used to this idea. All right, for number 3, if this was sine 2x over 2x, what would the answer be? Well, the limit of sine 2x over 2x would just be 1. Unfortunately, I've got that pesky third there, right? So my first step is I'm going to pull out. This is the same thing as 1. Well, let me run it this way. I want you guys to follow what I'm doing. So limit as x goes to 0. I'm going to pull that 1/3 out, because I don't want that 3 down there, right? You guys understand that so far? When I've got that number in there, what can I do with that number? Hopefully you guys are getting used to this with our properties. If you have just a constant in there, you can pull the constant out. And then you got the limit as x goes to 0. And then I'm stuck with sine 2x over x. What's wrong with that? Well, I don't have 2x in the denominator. In order for that guy to be 1, I've got to have 2x in the denominator. Well, I'm now back to this kind of problem that we just did here. And I'm going to do this trick and multiply it times 2 over 2, so I can get 2 in the denominator. So this would be 1/3 limit as x goes to 0. I need to get a 2 down here, so I'm going to make this 2 over 2 times sine 2x over x. So that's going to be 1/3 the limit as x goes to 0. I really don't need this 2 anymore, do I? Right? I just need the 1 down here. So I'm going to pull this 2, which is a number, out front and make this 2/3. And then sine 2x on the inside. And I need the 2 though down here and bring it with this 2x. Or 2x. Smart words. Wow. There we go. And now what's this limit of sine 2x over 2x? That's just 1. So this would be 2/3 times 1, which is just 2/3. All right. When you look at this, what are you thinking? Because when I'm looking at it, I see that 5 theta, which means I need 5 theta in the bottom. But what I have is a 3, and I've got this 2 on the top. I don't need either of those. So I'm going to pull those guys out, because they're constants. The limit of a constant is just a constant. And so that leaves me sine of 5 theta over theta inside the limit. What's the problem? What do I need in the denominator in order for that guy to be equal to 1? We need a 5, right? So we're going to go back to that same trick that we talked about up here. Leave the 2/3 alone. I'm going to multiply this guy by what? What do I need in that denominator? 5. Now, I need this 5 to go here, but do I need this 5 anymore? No, that one can be pulled out again. So now I've got 5 times 2 on the outside, which is 10/3, times the limit. Theta goes to 0. Now I've got sine 5 theta. This 5 went on the outside, I still have the 5 on the bottom, times theta, which is 5 theta. Now I know the limit of sine 5 theta over 5 theta is 1, so this is going to be 10/3 times 1, which is 10/3. All right, let's do one more for this video here. So for this one, I've got tan theta over theta. I don't have any rules about tan theta over theta, so the only thing I can think of to do right this second is to change this guy into sine theta over cosine theta. See if we can't make something work. And then this would be over theta. Just really theta over 1. So now I've got a compound fraction, so let's see if we can split it up. You have a fraction divided by a fraction, what can you do? Multiply by the reciprocal of these terms. Well, what's the reciprocal of theta over 1? 1 over theta. Alright, you seeing anything here? Well, I'm thinking if I can change the order of this, I've got sine theta times 1 and cosine theta times theta. If I can get the sine theta over the theta, and then move the cosine theta over with the 1, we'd be in business, right? So I'm going to rewrite this as sine theta over theta times 1 over cosine theta. Because multiplication is associative, you can change the order of it, we can do that, right? Sine theta times 1 is the same thing as sine theta times what? Cosine theta times theta, same thing as theta times cosine theta. Order doesn't matter, right? Not for multiplication. Other things like subtraction and division order matters, not for this one. Now I've got the limit of two functions, right? So I'm going to split them up using my property. So this limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of 1 over cosine theta. Right? And we know now this is one of our special limits. That guy's equal to 1. And I can plug in 0 here. So 1 over cosine of 0. What's cosine of 0? 1. So this is 1 times 1, which is just 1. All right, that's it for this video. Come back. We've got 4 more problems on the next video.